Welcome students. So now let's talk about can we improve upon greedy search. In the last video we saw how greedy search is used uh, to to improve the searching time of an algorithm by using heuristics. But can we do better? Uh, we have seen static search, greedy search is very fast, but it's not optimal. So can we do better and make this thing optimal? Now let's develop an intuition for an algorithm that will do exactly the same. And the algorithm name is A static search. But before we delve into the details of A static search, let us develop an intuition about A static search. Now let's suppose we are trying to traverse a path from S to G, and this is the path that we have found to be the most optimal path. Okay, so we are finding the best path, and the best path between S and G contains many nodes that form 1, 2, 3, 4, 5, 6, 7, 8, 9, and many nodes. And one of them node is N. So at this point of time, our search is stopped at N. This is the sub path of the best path that we have found so far. So let's call this thing G of N. G of N is the path cost that is on the best path between S and G, in which the N is the intermediate node. Okay. So this is the shortest path from starting state S to G, in which N is the intermediate node. Okay. And you remember this is the value that is used by UCS. So UCS only uses path cost. So UCS only uses f of G of N as its best value estimate. Now what is this path? Now this path is not traversed. We have to traverse this path. Now how do we find an estimate of this thing? And voila, this is what the heuristics are for. So we will calculate the estimate of this h of n. Let's suppose h steric of n is the actual path that is the shortest path between n and g. So we do not know h steric of n. But h of n is an estimate. So h of n is an estimate of h steric of n. Okay, and who uses this estimate? And you are right, this estimate is used by greedy search. So estimate of the shortest distance from node N to the goal node G, this is the value that is used by the greedy search. Now if you look that our total cost f of n, this is the cost from going to S to G, in which n is the intermediate node, is equivalent to G of n plus h steric of n. We know G of n, which is used by UCS, and we do not know h steric of n, so that's why we are using h of n, which is an estimate of h steric of n, and this is used by the greedy search. This is used by greedy search. Now this is what we are after. Okay, so why not use the both of them? So one is that cost that we have bared so far, जो cost हमें आ चुकी है वो G of n है, और जो cost हमें कम से कम आएगी वो H of n है. So asterisk, what asterisk does, asterisk combines these two costs. Okay, so let me just show you. So total cost f of n is the cost of the shortest path between S and G, where n is the intermediate node. तो f of n जो है जनाब, ये वो वैल्यू है जो कि asterisk यूज करेगा. तो जनाब UCS only uses this value, greedy search only uses this value, whereas asterisk will use both of these values. And just by using this value, it will guarantee that you will always find the optimal solution. This is the magic of asterisk search. So this is not magic, but I'm just telling you in a more figurative way of speech that it is a magic that happens when asterisk search combines these two values used by both UCS and asterisk. In short, asterisk is the combination of both UCS and greedy search. So how does it work? So asterisk is the minimization of the estimated path cost. So we always select the path cost that we think is the best possible of all the costs that are available. Okay, so asterisk what is doing? It's combining greedy search It's combining greedy search with uniform cost search. So again, the idea of asterisk search is always to explore the lowest cost node first. Okay, जिसकी कौन सी कॉस्ट नोड और कॉस्ट किसके ब्याज पे आएगी, कॉस्ट आएगी जनाब एफएन के बराबर, एफएन किसके बराबर, इट इज द कॉम्बिनेशन, द लीनियर कॉम्बिनेशन, और नॉट द लीनियर कॉम्बिनेशन, इट इज द समेशन of the actual cost from the starting node to n and the estimated cost that is from n to the nearest goal. So f of n is equivalent to the g of n plus h of n, the estimate cost of the cheapest solution through n. Okay, and the idea is if h static of n is the real cost, okay, that is from node n to the nearest goal, then we will have a notation of what we call admissible. So the heuristic function h will be admissible when it will always be an underestimate. Underestimate का मतलब जनाब ये कि अगर h static of n let's suppose कहता था कि जनाब जो amount है वो x है, then h of n should always be less than equal to x. ठीक है, x is some amount. तो जनाब अंडर एस्टिमेट का फायदा क्या होगा जनाब कि हम कोई ओवर एस्टिमेट नहीं करते. अगर हमारा फासला 100 किलोमीटर का था तो हमने कहा जनाब के लेट्स सपोज के एच ऑफ एन कह रहा है कि 80 किलोमीटर, इट्स नॉट टेलिंग 110 किलोमीटर. 110 किलोमीटर आर ओवर एस्टिमेट. एंड यू विल सी जनाब इट्स अ वेरी डिजायरेबल प्रॉपर्टी कि इट विल मेक श्योर कि आपका जो एल्गोरिथम है इट रिमेन्स ऑप्टिमल. ठीक है, अगर इस तरह सच ऑप्टिमल ह्यूरिस्टिक मेरा ऑप्टिमल नहीं है तो इस तरह सच जो है वो भी ऑप्टिमल जो है वो नहीं होगा. And we're going to show this thing in a couple of examples. ठीक है, so you can see जनाब के the only thing that changes for asterisk search is the fact कि जनाब f of n is equivalent to g of n plus h of n. And remember कि for greedy f of n was only equivalent to g of n, and for UCS h of n was h of n, and for UCS f of n was always equivalent to g of n. ठीक है, तो अगेन बट फॉर asterisk search f of n is always equivalent to g of n plus h of n. This is the main difference between the implementation of asterisk search, greedy search, and UCS. So let's look now. Let's see why an example why asterisk search will work on this on in this context. So let's look at an example. Again, example is the same. We are traveling from Arad to Bucharest, and we have these path cost as well as these heuristic values. So h of n. ठीक है, तो heuristic values भी हमारे पास given है, path cost भी given. Let's see how asterisk will work. Now the first thing you will notice कि जनाब के we are just not taking the path cost or the heuristic value, we are taking both the path cost and heuristic value. तो जो आपको जो value मिल रही है वो f of n जो है वो याद रखिएगा हमेशा g of n plus h of n. And why g of n is 0? Because you are starting, अब start करना है अभी, that's why g of n is 0. Now you explore nodes, तो आपने CBO को खोला, सिमिसोरा खोला, जेरेंद्र खोला, मगर आपने अब क्या किया, आपने पाथ कॉस्ट को ऐड किया ह्यूरिस्टिक वैल्यू के साथ. तो CBO की वैल्यू है 393, टिमिसोरा की है 447 और जेरेंद्र की है 449. तो द बेस्ट वैल्यू CBO, तो यू विल ओपन अप CBO खोलने के बाद आरात की वापस वैल्यू आई जनाब 646, फगरास की 415, औरदिया की 671 और रिमिसियो वेसिला की 413. आप देख सकते हैं तमाम नोड्स में सबसे छोटी नोड जो रिमिसियो वेसिरो है, तो आप इसको ओपन अप कर लेंगे. एंड देन यू विल फाइंड जनाब के यू विल हैव सम अदर नोड्स जिसमें क्राइबोआ है, पित्सेत्ती है, सिबियू है, और सबसे छोटी नोड जो वैल्यू आ रही है वो पित्सेत्ती की है. तो यू विल ओपन पित्सेत्ती. एंड आफ्टर पित्सेत्ती जनाब यू विल एक्सप्लोर अदर नोड्स, और नोड मिलेंगे जनाब ब्यूकारेस्ट और क्राइबोआ और रिमिसियो वेसिरो, और सबसे छोटी जो वैल्यू आ रही है वो ब्यूकारेस्ट की है. तो यू विल ओपन अप ब्यूकारेस्ट एंड व्हिच इज द gold node that you will have, and eventually you will find the best solution that you have shown so far. Okay, now let me give you a small exercise. So let's suppose you have a starting node like this, and you have two ways. You go to A, you go to B, and you have this gold node. So I'm going to write the heuristic values over here. So h is 2, h is 3. So basically it's 2, and so h is, let's say, 5. and so what should I do? So again, let me have this thing as 3 and let me have this thing as 2. So we have 1 and 4. Okay. So if you use a static search, then which node will you explore first? Or of course goal node की जो heuristic value, it will always be 0. The goal value at heuristic will always be. So take a moment and try to think that which node will you expand first. It will be A or it will be B. Again, if you have starting from S, the value of A will be 2 plus 3 5, and the value of B will be 1 plus 2 3. So B will be 3. So you will expand B, and then you will see this thing B plus G. So B plus G is so the cost for moving from G is 1 plus 4 5, and the heuristic value is 0 because and from A. So again, so which node will you explore first, G or A? So let's suppose K, if I have this thing as 2 as well, so you can have heuristic as 2. So the A will be 4. Okay, then you will not explore G, you will explore A because A has the lowest value. So you will explore A, and from A to G the value is 4, and then you will declare this as your goal. दैट मीन्स जनाब आपके पास दो ऑप्शन थे कि एस से बी जाए फिर गोल जाए, तो आपको कॉस्ट कितनी आई थी 5, और फिर आपको एक ऑप्शन आया था जनाब एस से ए आए और फिर ए से जी जाए, आपको कॉस्ट कितनी आई से 4. द बेस्ट गोल दैट यू हैव एक्सप्लोर्ड इज एस टू ए एंड जी. हालांकि आपको बी और जी पहले पहुंच गए थे आप, मगर उसके बावजूद आपने जो गोल एक्सप्लोर किया वो था एस से ए और ए से जी. तो इससे हमें रूल क्या मिला? रूल हमें मिला जनाब के ऑलवेज डिक्लेयर goal when dequeuing a node. तो जनाब हमेशा तब गोल डिक्लेयर करें जब आप नोड को गोल लिस्ट से बाहर निकाल रहे हैं, ना कि जब आप नोड को लिस्ट के अंदर एनक्यू कर रहे हैं. तो ये याद रखिएगा इस चीज को. नेवर डिक्लेयर अ गोल व्हेन यू आर एनक्यूइंग अ नोड. Always declare a goal when you are dequeuing a goal. This is a very important rule that you should understand. This is by default implicitly implemented in the algorithm, but when you are solving by hand, you may make this mistake. So that's why it's necessary always declare a goal when you're dequeuing a node and never declare a goal when you are enqueuing a goal. So this is a brief presentation about video about static search. In the next video, we will talk about why static search is optimal. Thank you.